Hi everyone, welcome back to another week of STEMpower. Today we will be learning about coding, or computer programming. You will learn about the basic art of computer programming through interactive exercises. You will learn how computers use various signals to decipher and translate messages. What is coding? Coding is the written language of computers. People use coding to give computers and other machines instructions on what actions to perform. We use coding to program the websites, apps, and other technologies we interact with every day. This week's fun fact is that there are over 700 different languages that you can code in. The first activity we will be doing is a Lego building activity. In this activity, you will learn how computer systems receive and carry out messages by simulating or mocking through a Lego activity. You will need paper, something to write with, and Legos, about 3 to 5 per group. You will gather into groups of 3. Each group should arrange their Legos in a specific formation. Please remember what formation your Legos are in and remember it in detail. You will now have 10 to 15 minutes to collaborate and write a set of directions, detailing how someone would take your Lego pieces and build the exact structure you just made. Please be as specific as possible in your directions. Other students should be able to do it without mistakes. You and one other group will then take turns presenting directions to each other. There can be one volunteer from each group that reads the directions and one volunteer from the other group who builds. After, compare the correct structure with the one the other group has just made. If you have succeeded, congratulations! If not, that's okay. If the builder realizes that they are confused, keep going. Do not explain your instructions, but you can repeat the same line again to them. Continue until your code has ended. The reader can make note of the confusion. For improvement. For the groups whose instructions didn't yield the desired results, discuss how they can be fixed. If you have time, you can test them out again. Discuss. What is a computer program? How can I start coding? What are mistakes in code called? A computer program is a series of instructions that tell the computer what to do. It is written in a programming language. Some examples are Python and Java. With computer programs, you can practically tell the computer to do anything you want, within a reasonable range. For example, you can code a robot to do your laundry. Now, you'll never have to do the laundry again. However, these codes are rather difficult to create, and that's why you don't have robots that do your house chores yet. Coding comes in all different forms. You can experiment with instructional videos and coding blocks on code.org, or use Scratch to make fun games. The errors made in the activity are similar to computer bugs. Bugs occur when there are errors in computer programs or systems. For example, if someone is given an incorrect or not specific set of instructions, they may behave differently than intended. If computers are given a wrong or too general piece of code, they may not do what they're supposed to do. The second activity we'll be doing is a secret message in binary. First, let's learn what binary is. A binary number is expressed in the base 2 number system, which uses only 2 numbers, 0 and 1. To make this more clear, let's break it down even further. Take the example of base 10. Base 10 is the number system that we use in our everyday lives. In base 10, we use the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. For example, 16 represents the number 16. Why? 16 has 1 tens place and 1 ones place. 16 equals 1 10 and 6 ones. There is 1 value in the tens place and 6 values in the 1 place. Binary is very similar. However, instead of using ones, tens, hundreds, and so on, we use ones, twos, 4s, 8s, 16s, 32s, etc. Take the example of representing 5 in binary. In binary, the number 5 is equal to 101. Why? It is because there is 1 4, 0 2s, and 1 1s. Let's do another example. For this example, I will be writing the number 17 in binary. As a reminder, I can only use 1s and 0s, and my number places are going to be 1s, 2s, 4s, 8s, 16s, etc. The number 17 is made up of bigger numbers, so I'm going to count all the way up to 16. Here I have 16s, 8s, 4s, 2s, and 1s. There's 1 16, 0 8s, 0 4s, 0 2s, and 1 1. When I add these all together, they make 17. So binary for 17 is 1 0 0 0 1. In this activity, you will become a computer that decodes and creates coded messages. You will need a pencil, paper, and a printed copy of the binary table. You can share this with a partner. You can write a secret message using binary code. You will do this by using the table. Each letter in the alphabet corresponds to a specific number given by the code, which is translated into binary. You should write your messages in binary, and remember to leave sufficient space between the letters or blanks, and keep your work neat and easy to read. In green, I am showing person A. Person A is writing the word summer in binary code. At the end of the activity, person A will trade code with person B, and they will decode each other's messages. You can trade your secret messages with a partner or a group so you can decode other people's messages. Discuss. What are binary numbers? What do you think binary numbers are used for? What are binary numbers? It is a number system that is based solely on two numbers, 0 and 1. In computers, 0 represents off and 1 represents on for each circuit. Binary numbers simplify the design of computers and other related technologies and allow for easy communication. Gottfried Wilhelm Leibniz developed the binary numeral system. He also developed useful calculus concepts. What did you learn today? What questions do you still have? Today, we learned about coding and computer bugs, as well as what binary numbers are. I hope you had fun today. I had a lot of fun teaching you about binary numbers and coding. I'll see you next week. Thanks for coming.